Some of you are asking about this question on the homework. So the vertices triangle GHJ are -4, -4 for G, -4, 4 for H, and J is 2, 4. Says if angle or start triangle KLM is congruent to triangle GHJ, find KLLM and KM. I'm going to do a couple of these. I won't do all of them, but what you need to know here is that when they start talking about ordered pairs, we're talking the coordinate plane. We're talking about this, and I put these points in for this thing. What's nice is that some of these points here, provide a horizontal and vertical line, so the process of finding those lengths is going to be pretty easy. And in regards to finding maybe J to G, that might be a little bit harder. But remember what we have to do when we talk about coordinates and finding distance. It's always distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's what we're going to think about in the back of our minds as we do these problems. So I'm going to find these distances of this triangle. Okay, so again, whether I have the picture or I don't have the picture, these 3 points dictate a triangle, and I need to find the lengths of those segments. So I need to find GH, I need to find GJ, and then I also need to find HJ. I need to find those 3 segment lengths. It might be a little bit easier looking at the picture, walking through that process, because if I look at the picture, it's going to be kind of easy to find the distance between H and J. If I look at those ordered pairs, okay, because it's a horizontal line, because the y values are the same, the x values are really the only thing I have to worry about. And to find the distance then of a horizontal line, it is simply your x values subtracted from one another, and you take the absolute value. So I'm going to take -4 minus 2 gives me -6. So distance is equal to -4 minus 2 gives me absolute value of -6, which is just 6. So H to J is 6. And if we ask GeoGebra to kind of find that area or that length, we see it gives us that 6. I need to do the same thing then to find the distance of H to G. And because it's a vertical line, it's the same concept. Alright, so we're looking now, because the x values are the same, now we're looking at the difference in the y values. So the distance of that is going to be 4 minus -4, which gives me absolute value of 8, which is just 8. And it doesn't matter the order that I subtracted those y's. You could have done it -4 minus 4 gives you -8. Absolute value of -8 is still +8. And then again, we should be able to see that distance again here as 8. So I get those 2 distances, so that's great, that's nice. Now we want to look at this and find G to J. Alright, now because it's not a vertical or horizontal line, you can't do these distance formulas that we use for the y's, y2 minus y1. We can't just use that for the distance between J and G, and we can't just use x squared minus x and the absolute value of that just for the horizontal aspect of that segment. So we need to use both, and the way we use both is this thing right here. We see here that's that component, it's the horizontal component, and this here is the vertical component. All right, and ultimately all this is the Pythagorean theorem. We've talked about this in the past, but distance now of G to J, so I'm just going to put G to J in here so we know what we're talking about, is equal to the square root of the difference in the x values. So I take the x values and subtract them. So -4 minus 2 will give me -6. -4 minus 2 gives me -6. I'll square that, and then add to it, okay, -4, the y value is subtracted, so -4 minus 4, and I'll square that. So it gives me 36 here. Answer going to be -8 squared is 64, so it gives me 64 there. So it gives me square root of 100, which is equivalent to 10. So I now know that that distance for this particular problem was 10. And we plug that in, and it tells us that it's 10. Okay. So now I'm going to go ahead and I've shown you the work to get those distances. I'm going to clear that work out and go back to what the original question said. The question said that triangle, let's see here, triangle KLM is congruent to triangle, oops, GHJ. Okay. Well, I didn't find KL and M. I did not have any. I don't have any. I don't even know what KL and M's points are. But all I'm asking for is what KL's length is. Well, KL's length better be the same thing as GH's length, their corresponding parts. So GH we found to be 8, right? So KL has got to be 8. And then they want to find LM. Well, LM are the second and last letters over here. So I better look at the second and last letters over here, HJ. Well, I know HJ. HJ was 6. And then the final part is to find KM. Okay, so KM is the first letter and the last letter. So over here I got to find first letter G, last letter J. So GJ was 10, so KM is 10. And now I've got those three distances that they're asking for without having any understanding of what K's ordered pair was, what L's ordered pair was, or what M's ordered pair was. Hopefully that helps. We can talk about this a little bit more in class tomorrow if we need to.